So now we have to decide whether the reaction is going to be an SN1 or it's going to be an SN2. And we have to actually make a flow chart of what we're going to do. The first thing that we have to do is that we need to classify the alkyl halide that we have. That's very important because, for example, if you have a tertiary alkyl halide, tertiary alkyl halides are going to form a carbocation, and the substitution we're going to do, it's going to be the carbocation mechanism, it's going to be the SN1 mechanism. If you have a primary alkyl halide or a methyl alkyl halide, then we cannot form any carbocations whatsoever, and we're going to have to do the SN2 reaction. So let's go ahead and just do a couple of things about the SN1 and the SN2. The SN2, remember that it's a concerted mechanism and that we need a strong nucleophile to be able to do an SN2 reaction. It would also be good if we use the right solvent, and the right solvents for the SN2 are what we call aprotic solvents. Solvents that don't have a partial positive hydrogen. So we have DMSO, DMF, acetone, and we also have acetonitrile, CH3CN. So those are our favorite aprotic solvents. There are more aprotic solvents. As long as you don't have a partial positive hydrogen, then you have an aprotic solvent. I forgot to put solvent here. In terms of the SN1 reaction, what do we know about the SN1 reaction? Well, we know it's a carbocation mechanism. We know that the nucleophile can be a weak nucleophile. Our weak nucleophiles are going to be water and alcohols. And we also know that we use water and alcohols as a solvent, so your nucleophile is your solvent, and that's why this reaction is called solvolysis. Now the ones that we don't have here are the secondary alkyl halides. Those are the tricky ones because they can undergo the SN1 or the SN2, and you have to analyze the conditions that you have. Now, if your alkyl halide is a secondary, you're going to actually classify the nucleophile. If your nucleophile is a strong nucleophile, then you're going to do an SN2 reaction. If your nucleophile is water or it's alcohol, so it's a weak nucleophile, then we're going to be doing an SN1 reaction. Now this chart that I have here doesn't take into account the possibility, the competing reactions, because we're going to actually do those in a separate flow chart. So if you actually have a strong base, which could also be a strong nucleophile, but strong base mainly, you're going to do an E2 mechanism, and that is another video, so go look for it.